This is Neil Patwari. I'm going to talk about, in this segment, the case where we end up with two limitations that conflict, and we're going to end up being more conservative than we need to because we have to meet both constraints at the same time. Specifically, I'm going to talk about when we're given a C over N naught ratio, or equivalently, we're given the noise and received power model parameters in order to get to the C over N naught ratio. We're also going to be given a bandwidth constraint. That's a very realistic case where we have limited bandwidth. And we're going to be given a probability of error constraint. Again, a very realistic constraint that we know something about our application and we want to design for that. So given these three constraints, we still have a lot of work to do to figure out what modulation to use. And these are constraints, so typically for probability of bit error, we need to have less than or equal to the given probability of bit error. For bandwidth, again, we need to have less than or equal to the maximum bandwidth we're allowed. And C over N naught ratio, we're not allowed to have greater than this C over N naught ratio. And what we do is we have to start with some assumption about whether we're energy limited or whether we're bandwidth limited. We're going to start with the case that we have an energy limited system. And I'll talk about why it is named that in a second. But what we do in this case, this is method 1. I'm going to just number it so I can refer to it later. We're going to start with the probability of bit error, and we're going to use the modulation we're given in order to calculate the EB over N naught. From that EB over N naught, we're going to use the constraint on the C over N naught ratio to calculate the bit rate. And again, using the modulation, we're going to convert that bit rate into symbol rate. And using the pulse shape, perhaps, that we're given, this is where we use this, we're going to convert that into a bandwidth. So this red bandwidth that we get, we're going to compare to the constraint. And if the bandwidth that we get is greater than the constraint allows us, then we're going to end up with deciding that we were not energy limited. In fact, we were bandwidth limited. So in that case, we're going to have to start again with method 2. But if the bandwidth constraint, the bandwidth that we calculate is less than our constraint, then we're good. Less than or equal to, I should say. Then we're great. So it's really in the case that the bandwidth doesn't meet the constraint, then we know we're bandwidth limited and we need to try something else. So I'll talk about what to do next. We can try method 2. So in method 2, what we do is we start with the bandwidth constraint and we go up with the given bandwidth and a pulse shape. We can find the symbol rate. We can then use the modulation, the M value, to find the bit rate. And using the C over N naught constraint, we can compute the EB over N naught. And given the EB over N naught and our modulation, we have lots of formulas for the probability of bit error. And we can compute the probability of bit error. And then, once we have that probability of bit error, we can say, how is that probability of error, bit error, compared to our constraint? If it's less than our constraint, then great. We're done. We have a bandwidth limited system. If the probability of bit error, then we have an energy limited system and we should have used method 1. And while I called these method 1 and 2, and your intuition would be to start with method 1 and move to method 2, there is no ordering here. You can start with either one. If you get to the end and it tells you that you need to start over, then you would switch to the opposite method and try the other case. Alternatively, I'm not really talking about this, but we can change the modulation. So we have a third choice, really, a method 3. where we alter the modulation, either the M or the type of modulation entirely, to FSK or to some other method of modulation that allows us to achieve our goals better. That is, to achieve closer to the constrained probability bit error and closer to the constrained bandwidth. Okay, so these are our options, and I'll go through an example next.